my slide now. And I will open. So I will click on detail. Once I click on detail, it will open up detail app. So here we have details. So as mentioned, I will be using this general options right here. I will change the code to AASHTO and our concrete grade to be 4,000 psi. Okay, and reinforcement grade to be 60.
Jadi kan mereka mau ngomong harus memasukkan
To click on create.
Harusnya dengan poin 1 itu
Alright, so
mereka udah paham
here
ini kan kita minta
I'm going to
untuk
export
menjelaskan
our model based on this geometry right here. We have prepared the DXF model. So from here, I can just basically click on DXF import. I'm going to click on member. I already have applied it
Mungkin ada
here, and I
historical
just
juga
want
sih,
to do it
historical.
on open.
Maksudnya kan
So from the
ini
geometry of the
perubahan
structure,
penanganan itu,
I just select the concrete
ini kan
face,
dari rencana
and from these options you have
mohon
the
dijelasin.
insertion point where either you can use the DXF origin or the center of gravity. I would since I was working on DXF, I would rather leave this as a DXF origin. It's much easier in terms of insertion point. I just click on outline, I click on OK, and you see the shape of the added. You can also add another one,
mungkin dibikinkan matriks seperti itu ya.
Which is also again, and I click on member. So you can either choose a single selection like what I did here. Click on OK. But you can also select multi-selection by pressing just the control button. So if you press control button, you can basically select all the required members. That is, oops, sorry. I just select the press the control button and press the necessary, select the necessary member. So it would be much faster. That's okay. So you have two options to do it. Yeah. And you can see from here, our member is already added. No, but of course we need to have correct geometry of this. We need to adjust our thickness here. So the thickness of our parquet is actually 1.8. And the thickness of our pier is actually 1.25, which is a circular one. And at the end, this will follow the same thing. I can just press and hold control button, 1.8. And I can, at the same time, I can also
Selain bahu yang dianu nggak ada lagi.
Press it right here and change. This time, this is 0.5.
Tipikal jalannya.
Yes, no? Now that we have right here, we need to provide our boundary conditions or the support. So all I have to do is just click on model entity, select line supports, and I can select member number 2, and of course I can just select to which edge I would put it in. So I just put it edge number 3. I would then disable the compression only spring support, and I will activate the rotational constraints right here. So basically we have a 3D model in this case, similar to our model right there. So from here, we basically can add loadings, no? But before that, we need to have a transferring device. So in order to do that, transferring device, oh, sorry, I pressed the wrong button. So under model entity, I click on transferring device bearing plate. And I will change the width to 0.45 and the thickness of the material is about 100 now. And I will change the width to 0.45. Make sure that this is actually placed in this position. Materials about 100. The good thing about this is that this is to under one. I just have to make sure that this is actively placed to this position. You have here the materials about 100. The good thing about this and I will change to under one. I just have to make sure that this is actively placed to this position. You have here the materials about 100. The good thing about this and I will change to under one. I just have to make sure that this is actively placed to this position. You have here the materials about 100. The good thing about this and I will change to under one. I just have to make sure that this is actively placed to this position. Here the materials about 100. The good thing about this and I will change to under one. I just have to make sure that this is actively placed to this position. Here the
Now from
materials
here,
about
I
100.
basically can
The good thing about this and I will
edit
change to under one. I just have to make sure that this is
remember the
actively
one that
placed to this position.
I've shown now for the table, you can add it from here. I can add it right here. I will name it. Remember the one that I want to take this table, you can add it from here. The construction tree. I can now add southway. And I can add a tree for close that we have. If I go back from my presentation earlier regarding this loading criteria, this is the load that we are going to do. So from here, I will put again this loading criteria, so 5, 1, so I will go back copy, 5, it's much easier with all these structured devices. You can just assign directly there. The node. Then again, it's much happier with all these structured devices. 3, assign directly there. Happier with 4. Again, it's much happier with adjust the node devices. 3, assign. Now I can make this as a pattern, which means that I can also copy this same load case. On the permanent load, I can just change. I can make this as our window programming center. And since we already have the self weight and the superstructure weight, which is what we're asking for, I will choose just use this set for the window. So we don't have to double our factors or the load case. In this case, I have 100 to minus 180. Minus 180. And then minus 100. And the same thing with live loads for our HL93 track loadings. I'll just have to copy, but this time I will change this to load case type function. So I can rename this to rename LL HL93. All right. So from there, I can put in the loads again, minus 5, 12.5, same thing, minus 244, minus 244, minus 512.5. All right. Now, now for our special vehicle loadings, I can simply copy the same thing, but for this one, we have a much higher loads in this case. I'll just simply replace it with minus 657.5. Okay. All right. Same here. And this one to be minus 657.5. This is supposed to be minus 328.8. Same with things here. All right. So I can now basically create a load combination out of this. Oh wait, I forgot to put our wind load on structures. Sorry about that. Let me just click load case. I would still put it under transient. our wind curves load 4, wind on structure. This was on wind on vehicle, wind on live load. So here, going back to these loadings right here, we have here some horizontal forces. I'm going to how do we apply that horizontal forces? So those actually we cannot apply that in the bearing plate. So we need to transfer that into our concrete horizontally. How we should do that? The options that can do that is by using patch load in idea statica. So here, as you can see here, this patch load. And how does this patch load actually do? Is that it allows the transmitting of the load directly to the reinforcement located within the area of the effective radius. No, this is actually to secure the functionality of the patch load to a group of rebar that will be later interconnected with, which is the necessary to define the loads in the reinforcement. No? Just there. So I'm going to click on patch load. So here we can apply patch load basically on every things right here. So let me just apply that patch load under number 3. So we have some insertion points as well right here. All I have to do is click on insertion number 6, and I'll just have to put position to be 0, 0. Now I want the radius to be, I want the loads to be applied at the entire surface. So I'll just increase the radius similar to that of the size of the nib here structure. And again, this can be copied easily to the rest of the structure itself. So I can just click on copy over here and do that. I'll just copy it under 4. I'll put that 8. So obviously it can be transferred. Copy again, same thing. Just change it to number 6. So it's basically just a copy of everything, no? You can do the same thing here. I'll change it to 5, change it to 8, copy again, change it to 6. So it's much quicker basically. I'm putting it at 6. I'll have to put in master 8, copy again. I'll put it at 6. So it's basically applied everything. Let me do the same thing with the last one. And basically from here, we now have our patch load assigned. And you can see that there is no reinforcement reference already in the non-conformities. We can solve that one later on. From here, I can now apply my loadings for the wind loads on structure and wind load on vehicle. So I can just, again, point loads. I'll change this to global X. Here, our point load is actually, our horizontal here is actually 13.5. And I will just assign it to patch load number 2. So here it will be applied directly in this case. So what we can do, obviously, just copy again. I can just apply it to patch load number 4. This one should be 7.1. I will copy that again. Should be number 6. I will copy that again. And this should be number 8. So this should be 13.5. So our notification that the loads is or that there's no load already disappear. But there is still some non-conformities here because we don't have the reinforcement yet. But from now, I think we can create a load combinations out of this. So as mentioned, I will create the load combinations, delete, based on strength. I will change it to strength number 1. one, and all I have to do is click on this one. I'll just click a copy. We have 5 combinations, perhaps. Going back to our right here, we have 5 load combinations for strength, and we have 2 load combinations for serviceability. So I'll just have to copy, 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 and I will create a load combinations for service. So I just create rename service 1. I'll copy again. This will be service 2. So this will be under total loads, and this will be selected. This will be both serviceability combinations will be active for crack width check and also deflection check. No? So I would have to add load factors right here. So here, 1.25, 1.5, 1.5, oops, 2.33. This would be 0. This would be 0 as well. So here, it's basically just the same. 5. This one is 0. This one is 1.69. This one is 0. 1.25. String 3 is 0. This is 0. This is 1. Correct. 1.25. 1.5. String 4. Live load is 1.8. This is 0. This 1. 5. This is 1.8. So I made a mistake here. It should be 0. This should be 0. And then here it should be 0. And this should be right 0. Now we have our complete nonlinear combinations right here. So basically, now that we have our we have our loadings, we can basically create now the loads. I mean the reinforcement. But I have one very useful tool that I want to show is actually the use of typology optimizations. No? Typology optimizations is actually the method is that it aims to find the optimal distributions of material in a given volume for a certain load combination. So if I click on topology optimization right here, it actually analyzed based on the compression field and tension field. So later, once it is, I will show you how does it look like. All right, so I think it's a couple of seconds. It should be okay. So what this do is actually something to the strat and tie method. It will show you the compression field and the tension field within the given loads based on the loads that we have applied. So you can see here from what you see here, red represents compression and the blue represents tension. So this actually gives the designers an idea how to lay out the reinforcement in this case. So you can also adjust the effective volumes. How does this look like in here? So from here, based on this image right here, we can actually strategically apply our reinforcement. No? So I go back to my design. Now I can basically just apply the reinforcement using the DXF method. If I want to apply rebar, I can either, there are a few steps that you can either use. The first one is actually use these options right here, using a group of bar. And from here, you can select which member. For more edges, I can change the diameter type to user input instead of ASTM. So let's say I want to use 25 mm. And I can assign to just, number 1. Okay, so I can make use of this. So I can just follow the edges where I want to put, no? Because Aesthetica gives you the edges right here. So I can just say, I want to apply it on the 8, 11, 14, 15. You can just say 16, 4, and 6. So basically, the program can follow that. So this is one of the options. And another option is actually the use of DXF import, no? So I can just click on import and go back to the image that I have shown earlier. So here I can also use this one. I can just click on select. And there the reinforcement also applies. So this is actually much easier, you know? So these options will help you identify which possible procedure you can follow, but I would suggest which options is much more convenient for you. I would suggest that you use that kind of options. So again, I will just continue with reinforcement here. So for example, I want to get rid of this non-conformities right here. I will put in this reinforcement. Again, I can also make use of a control button instead of just simply doing it one by one. I can just press control button and then select the required reinforcement. See, I just click on select and I can click on OK. So all this reinforcement will be also added. But then we need to go back to our patch loads that we need to link this together. So from this, I will just select this 5 reinforcement right here. I would like to connect it, interconnect automatically. So once this patch load support here is connected, all those notifications right here will disappear. So that is basically how you're gonna design the reinforcement in this case, no? So supposing we have completely finalized all the reinforcement by following the steps that I've shown earlier. I have here the finished reinforcement already prepared for you using the DXF options that we have provided. So from here, basically, we can analyze now, since we have already prepared the reinforcement, we can click on calculate. If I click on calculate, of course, it would gonna be analyze the whole structure. To save us a little bit of time, I have already prepared the results for this, which is this one. So as you can see, based on the results, you can see here the stress flow diagram of the entire Pier cap. And we have here the general overview of the results, the strength, and the serviceability. So as you can see here, we have some failures in a crack width. And if we go through our strength as well, the stress and the check tab, you can also see the reinforcement, the stresses in the concrete and as well as in the reinforcement. And if you go to anchorage tab, okay, it's a little bit frozen. Just give it a quick second. You can also see what are the anchorage stresses here. Here in every reinforcement, there are values of each reinforcement. What is going? You have here the limits and also the bond stress. And if you go to serviceability, you have here the crack width as well. So we can see here that we have some crack widths failing. This is very important to look at, especially when we are designing bridges, because we don't want our bridges to basically fail in such a manner like what you see in the image right here. So, for example, here we have a crack width, and based on AASHTO requirements, we have some limits. Basically, we have some specification on crack control. We have some exposure conditions that is requires the spacing of non-pre-stressed members in this case, and we have some tabulated permissible crack width as well based on Article 5.6.7. And we can basically make use of some, depending on the exposure conditions. If your structure is located in a much more exposed to this kind of conditions like chemicals or seawaters, you will have a much stringent crack width requirements. So in this case, right here, we do have some crack width right here. It seems like our limits is basically more than that. Yeah, I mean, the result is more than the required limit. But as you can see right here, that is actually affecting just the this reinforcement right here, which is not really that significant in terms of the structure right here. But what we are more what we are more concerned is actually the main reinforcement right here, which is, for example, here we have crack width which is 0.275. This actually affects if your, for example, your exposure condition is very much critical. And although this is passing sometimes in here, but it's always that the code will govern that whether you want to use a different limits for your crack width. Here you can adjust right here, and in order for this to make it work. No, the good thing about this is that you can, by just hovering your mouse, you can already see the results of the crack width. So what I'm gonna do right here is basically, of course, I can also adjust the reinforcement by making the size of the rebar bigger for the main reinforcement, and I can also adjust some stirrups in this case. So supposing we have added that adjustment to the reinforcement, and we have to analyze once again. For example, here I have adjusted the spacing of the stirrups of the main pier cap, and then we analyze. We have here the full results, which I have already prepared for you guys. If I'm going back to these results right here, so this is now the full results in the when we adjusted it accordingly, our main reinforcement and the stirrups. So going back to crack width here, from previously we have about 34%. So basically we are now passing in this case. What I did, as mentioned, I adjusted the spacing of the stirrups in order to have it work. No? So we can also check on this deflection right here. How big is the deflections right here? And as you can see, we have some values here not over the limit, so only 25% based on the 20 mm that we have specified right here. So since we have already checked it over here, I can now go directly to the report and say I can just click on generate report, but you can also place some info over here, some user paragraph if you want to. Here I even added some of the screenshot or some images. You can just basically click on this and you can actually add pictures wherever pictures that you like. And once you have that, it will also, once you generate in your report, those adjustment that you just made will also appear. So once I click on generate, it will generate my report here. So here I have here my project data, and of course the summary of the checks and all the loads that we have done, we have input so far, which is pretty much useful when some checking engineers will look through your design works and see whether everything is okay. You can also see some of the reinforcement materials right here. So that's basically for a very quick demonstration on how to use our program Idea Statica. So I would give back the screen to Jan. Jan?
Thanks, Gene. Thank you very much for the presentation, and I have. Oh, sorry, wrong slide. Sorry. Okay. This is my slide, and I have the last poll. So you have seen the capabilities of CSFM method in Idea Statica, and I would like to ask all of you whether you would consider using CSFM method in Idea Statica to design the regions and infrastructure projects. If you are not in infrastructure, you may also answer, of course. Yeah. So there are some people who are not designing this. So if you don't deal with the bridges, but feel free to answer. Okay, 28%. You can be honest with us. If you don't see any potential in there, just put no. And we would like to hear your feedback, because also our developers are asking if they are developing new things. What does the user say? And if you want to share it. So last 5 seconds, please. Only 52% voted. Please share your feedback with us. And I am finishing it right now. And let's see the results. So very good. 44% wherever appropriate. 10% only for structures with complex regions, and 37% need to know more. Of course, we can connect after the webinar individually. You can approach us and we can discuss whether CSFM method would be appropriate solution for your engineering problem you are dealing with. Of course, there may be some situations and we may say maybe this is not in the capabilities of Idea Statica, but many of them we can confirm that after the discussion that it would make sense for you to try. All right, thank you very much. I'm closing the poll, and we are heading towards end. So just quick summary. If we compare CSFM method and strat and time method, both can be used to solve 2D problems. Both are according to AASHTO, so they are following the limit state method in AASHTO. Both have AASHTO ASTM material models. Both can do ultimate limit checks. But if we go to serviceability limit checks, strat and time method module is limited. So you cannot check stress limitation for pre-stress members. You cannot easily check the crack width and deformations. Also, time savings, if you are dealing with more complex geometry in Statica, it can be much faster. You saw like how Gene was able to import everything from DXF, set the loads. Of course, in the real life, it would take slightly more, all the steps, but still we are talking about just a very short amount of time compared to a certain time method. What's important that we have really accurate results in these regions so we can properly check if there is not a crack somewhere where we don't want a crack, because crack means problem or excessive crack means problem. So we have safe checks. We can also use it to optimize the material, because sometimes we tend to put too much rebar to avoid cracks. So depends what we are looking for. We have the verification for ULS and SLS. It's fully compliant with AASHTO. And of course, it supports also other codes, Eurocode, ACI, and Austrian standard. So any 2D region can be checked using Statica. All right, so we are heading towards the end of the webinar. So what to do now? Many of you attendees today are existing users of Statica. So if you don't have the latest version, just go to our web and download it in product downloads, because the AASHTO capabilities of Statica detail are included in the version 26. So you need to have the latest version, and it's included in the concrete, complete, or enterprise edition of Statica. If you are not sure what edition do you have at your company, ask your admin or just click the license button on the top right corner, and you will see the configuration in available products. So you will see whether you have enterprise or steel only. And if you don't have an access to Statica, either having older version or not any of those editions, you can ask for quote request or scan this provided QR code and fill the form, and then you will be contacted by our partners. And if you want to discuss more, because many of you mentioned in the poll that you are not sure whether it would be a good application, you can contact directly us or our partners in your countries. So feel free to drop an email directly to us. We can arrange a quick one-on-one discussion and just validate whether your use case can be solved using Statica. So we are open to discuss further. We are running out of time. There were some questions. We answered most of them. Okay, there's more coming. So please ask more. There were some questions whether we can assess also not reinforced concrete or only partially reinforced concrete. Right now, the method is primarily for reinforced concrete, so minimum reinforcement is required. But we also have a 3D CSFM. Right now, is primarily used for anchoring design. And we are currently now validating its usage to general 3D shape. So our goal is to have this solution also for 3D and also just partially reinforced areas. So like, for example, footings, pile caps. Yeah, we see a lot of potential there because many existing users are already asking for this. So we are now putting the effort to develop it also together with the universities we cooperate with. I'm just quickly checking the questions. There was a question whether we'll provide the slides. So after the webinar, we will provide you the recording of the video, so you can refer to that video if you need to do this. There is also a question from Ruben whether we can see the calculations, expressions. Yes, in the report you can turn on like more detailed formulas. So it's possible. You can actually set what you need in the report. And 3D feature, I already mentioned it. Yes, many of you is asking for 3D features. 3D. I just wanted trial version to check. Yes, trial version. Okay. Let's move on. We're running out of time. So trial version, you can download it on our web, ideastatica.com. On the right corner, 14 days trial version. You can also go to the support center, find more case studies, technical articles. So please do it after the webinar. And also I would like to ask you to fill the short survey because we would like to hear your feedback. How useful was the webinar for you? What are the topics you are interested in for the next webinar? So please fill it. And also you can find the recording in our support center under webinar section. And yeah, that's it, what I wanted to mention. So please go test it and contact us if you have any further questions. And we are looking forward to have good discussions and also hearing from you. What else would you need in Estatica to be developed to solve your engineering problems? All right, so that's it. Thank you very much and see you at the next webinar. Thank you.
Thank you. Bye-bye.